So if a function is one-to-one, it has an inverse function. If it is not one-to-one, then it has y values that repeat. So if it's reflected about the identity y equals x, then the x values would repeat and it would not be a function. So if a function is not one-to-one, it does not have an inverse. So let's look at the parabola to the right in red. That's a function. We know that. We know it's not one-to-one because it would fail the vertical line test. But graphically speaking, the blue parabola that opens up to the right is a reflection of the red parabola, but as you can see, it fails the vertical line test because it would have repeating x values, so it's not a function. So example 6, find the inverse of each one-to-one function. So how do we do that with a mapping? Well, we just take the output, which is the money here, and we'll do $10 and $20 and $40 and $80, and we will map it to the values in the original inputs. So we'll map that to 15 miles, 40 miles, 90 miles, and 200 miles. I'm going to squish that in there. So we're just switching the inputs and outputs. So this would be the inverse. If this was F, this is F inverse. For a set of ordered pairs, we're just going to switch the x and the y values. It already is a function, so the inverse would be 0 and -11, 1, 4, and finally -5, 6. So this is the inverse if this is the function. And finally, with a graph in part C, how do we sketch this? Well, remember it's a reflection over the identity y equals x. So really all you have to do is figure out, I'm just going to use the 4 points that are kind of where the graph changes direction. And if I have to go down exactly, how do I get to the line y equals x? I go down vertically 2 points from this first point here, so the inverse would be directly to the right and map there. In other words, I could actually figure out that this is the point 3, 5, and I need to graph 5, 3, but I'm kind of doing it just understanding that I need to take the vertical distance. If I have to go down to the line y equals x from 1, 2, exactly 1 unit, then I go to the right, and that would be 2, 1. So I'm kind of doing it visually. So this was 5, 3. If this is 1, 2, this would be 2, 1, but I'm not even going to do the next point. I'm just saying I go down 2 units to get from this point here to the line y equals x, so I just need to go to the right 2 units to find that point. So last one is actually on the line y equals x, so I don't have any distance, so I would be there. So our inverse function would look something like this, and I truly am just connecting the dots. So the green is the inverse of the original blue function that was given. So we're reflecting about the line y equals x. Or you could just give the coordinates of each of the points to help you draw the graph and flip the x and the y values.